Hello and welcome back for another VMK in the game development series. In the previous VMK, you saw that we could output text to the console window, but we didn't have the ability to actually display what is being typed in on the keyboard. Now what we're going to be able to do is type text on the keyboard, and whatever we're typing is going to show up inside of our console. So let's get started. To start, we're going to have to go into our console param structure and add a couple variables into here. There's going to be sz input, which is going to be of size console max length, and we're going to have an integer value which I named here ichar. This variable here is an array of characters which is going to store exactly what the user's typing. So anytime a keyboard letter is pressed, that value is going to get saved inside of this array. This variable here is going to contain a number that tells you which current value we're going to be trying to store inside of this array. So for instance, at the beginning this is going to be set to 0, which means we're going to be saving the very first character inside of this array. As soon as you press the button, this is going to increment by 1, and the value of whatever you press is going to get stored here at 0. Then the next letter that you press is going to go to the next location, next location, next location. So that's the way that that's going to work. We need to define console max length, and I'm going to do that inside of core.h. Let's see here. Actually, I don't see a... I'm looking for a define called line max length. That's the one that we used before for parsing text out of our text file. Let's see where I placed it. Well, here it is here under scene.h. Well, we might as well define our max length up here then. So I've set the console maximum length to be 10 characters long. This number here, whatever it is, must be larger than 1 because the code will depend on that. We're going to go in and change this value a little bit later, but I'm going to leave it at 10 for now because I want to be able to demonstrate something in this video near the end. Now, we also need to go in and initialize these two new variables. So let's do that here in the constructor. So I set the character value to be 0, and we're going to set the entire array sz input equal to 0 for every single value inside of the array. Now 0 is a special number that is used whenever working with character strings, because 0 represents a null terminating string. So whenever we use sprintf or printf function calls, it knows that when you pass in a string, it's going to keep printing until it sees a 0. As soon as it sees a 0, it'll know to stop. So by setting all the values inside of this array to be 0, we have basically a completely null string. Okay, now we need to be able to override the keyboard presses so that as a key is being pressed, we'll go in and save values inside of the string here. To do that, we need to go into our, let's see here, game engine, game OpenGL, message handler. Anytime a key is pressed, we go inside of this key down case. We're going to be going into this else statement here whenever we're typing letters on the keyboard, so we're going to have to change this structure down here. What I do here is I check to see if the console is open. If it is, then whenever you type keys on the keyboard, we want to actually be saving the value inside of the console string. So that's why we call this console input function here, and we pass in the value of the character that was being pressed. After we process this, if this returns true, then we want to immediately set the value of m_b keys back to false because initially we set it here to true. This is very similar to the way we've handled the flashlight in the previous VMK. We only go into this section here whenever the console is open because we still want to be able to have the same functionality that we had before when the console is closed. So for instance, if you press the W, S, A, or D keys, we don't want to display that to the screen. We actually want to be able to move our character inside of the 3D world. However, when the console is open and you press W, S, A, or D, we actually want to see W, S, A, or D showing up on the screen. So that's why we need this if statement up here. Alright, so now we need to implement this new function here called console input. So let's go into our scene.h and implement that function. The function itself is going to return a boolean, and it's going to take in a w param, and I've labeled here it as the VK code. So it's the virtual key code that we're passing in. Let's save that and open up scene.cpp, and I'm going to implement this console input right underneath console toggle maybe, or actually right underneath frames per second toggle display. So here we go. We check to see if a key is pressed while the console is open. If the key is one of the ones we want to handle, then it will get saved inside of the variable so that it can be displayed on the screen. We also need to return true if a key is handled, otherwise we'll return false. First thing we need to do is check to see if the character number here is greater than or equal to the console max length minus 1. And we do this to make sure that we don't save more characters than we have room inside of our array. So if this is true here, then we don't have enough room anymore, so we just return true and we don't save any new characters. If there is room, then we go down here below. We'll begin by just looking for letters. Everything here is going to depend on the ASCII values of this key code that is getting passed into us. And again, if you go back to ASCIItable.com, you'll be able to see the ASCII table for all the character sets that we'll be using. For the letters, you can see here the capital letter A starts at decimal value 65, and capital letter Z is up here at 90. So we're going to check to see if the key input is between 65 and 90. We go into a for loop between 65 and 90, and we check to see if the key code is equal to one of these numbers. As soon as we find a match, we then take that specific index in the array and set it equal to whatever the value was of this key code. So that's the letter between A and Z. We increment our I character value so that the next character that we save is in the next location, and we return true. Down here, if we don't find a letter, then we just return false, meaning that we don't handle that specific character that was being pressed. Now the only thing left to do is to render this character string into our console window. So to do that, we need to go into console render, and let's see here, we render the actual rectangles, and we want to be displaying the user input here on line number 1. So that's going to go right here on line 1. We have our two greater than signs, and then we're going to have %s, and we're going to specify our string that we want to display to the screen. So let's save this, build it, and see what happens when we start typing on the keyboard. Oh, we have some errors here, so let's take a look. Unidentifier C. Forgot to define this guy. We're going to be using this letter C quite a bit, so I'm going to define it outside my for loop so that later on when we add extra for loops in here, I can continue using the same variable. Let's try this again. Okay, I think, oh, we still have one more error. What did I forget this time? We're missing a bracket here. Okay. So now when we're running, if I open the console and let's say I type hello, you notice that it's displayed on the screen. This is great. Now let's type hello world. Notice that I'm stuck with only a certain number of characters, and if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, I have 9 characters which are allowed to be displayed on the screen. That's basically 10 minus 1 because our limit was 10 characters long. Also, the other thing is, notice that after I type something in, I can't get rid of this text. If I press space, enter, backspace, nothing, there's no way to get rid of that text. Well, we have to handle a special case inside of our console input function to be able to delete text or overwrite it, things like that. Right now, all we're doing is saving the first 9 characters, and that's it. So that's the way that this code here is working. Let's go into our scene.h and increase our maximum length now. You've seen now that this basically limits what is the maximum size of characters we're allowed to type in. I'm going to change it to 100. I think that should be plenty for us to work with. And let's go back into our scene console input function. Okay, let's go and handle the backspace key. So we'll use this to delete the previous value that was typed in. The way we do this is we check to see for the virtual key code back, and then what we're doing is we decrement the I character value. We then check to see if that value is less than 0. If it is, we automatically set it to 0. What this does is it makes sure we don't back over the minimum value of our array. So if we had like four values typed in already, we don't want to be able to delete more than 4 characters, because if you did, then this value here would be invalid because you're now pointing at memory location -1 here inside of this array. We can't have that. So after we correct for this value, we make sure that we overwrite that previous value to be 0. So in other words, we're replacing whatever was there with 0. Now let's go save this, build it, and run it, and see if our backspace character works. So now, if I open console and type hello world, and I press backspace, you notice I can delete the text and then add in whatever I want. Okay? And if we delete back to the very beginning, if I continue pressing delete, you notice that the program doesn't crash. If we didn't have that extra if statement there, it would definitely crash. Alright, so we are able to type text in and we're able to delete it as well. Now, let's go in and modify our code so that we can handle the space. I'm going to place it right above the look for letter section. It definitely has to be below this check here because we need to always make sure we have enough room before we add anything into our console param setInput array. So what we're doing is we're looking for the space code. If it's there, we're going to take the space value, stick it into our array, increment the ichar value, and then return true. So here we go. Now I should be able to type hello world with a space. So that's working well. And if I have multiple spaces, you can see that gets saved as well. Now, we will be using a few other special characters within the character set. So I'm going to add them here underneath the letter section. We're going to be looking for commas, periods, and the minus sign. For the comma, this comma is located on the keyboard beside the capital letter M. So when you press that, then we're going to stick in a comma character into our array. And again, increment the value here and return true. Period, there are 2 different periods you can press on the keyboard. There's the one beside the comma, or there's also the one that's located on the number pad. So to handle both of those, we have both checks here. And for the minus, we also have 2 different minus signs. You have the one on the keyboard and the one located sort of above the P sign and beside the 0 that is not on the number pad. So there's 2 values for the key codes here. Okay, so that's the way we handle those special characters. There are also numbers. We want to be able to type in numbers because later on we're going to be parsing this text and actually using it to do something interesting. So we can right now type text, type spaces, and type commas, periods, and subtract symbols. So to add in numbers, let's do the following. We're going to define char C up here, so I'm going to get rid of this guy down here. We no longer need him. And we're going to go from ASCII values 48 to 57. And if we bring up the ASCII table here, 48 is here, so that's number 0, and 57 is number 9. So that's where we get this first section here. These are the regular numbers that are being pressed on the keyboard. Now we also want to handle the number pad numbers that are being pressed. Now to handle the number pad values, we need to take the value here between 48 to 57 and add 48 to it. Now you may be wondering why 48. If you look at the ASCII table here, where are we? 48. If we take 48 and we add 48 to it, that's 96. And 96 looks to be the apostrophe character. So that doesn't seem to be right, but in reality it actually is. The key codes that we're using here are not necessarily the ASCII codes that I've been showing you in that table. There really are a separate table for these key codes. To see the actual values of all these key codes, what you can do is just select, for instance, VK underscore space, right-click on this and go to definition. This will open up winuser.h, and this is where all the key codes are being stored. Some of them we stored ourselves inside core.h for the keys between 0 and 9, as well as for the letters A to Z, because they're not actually stored in here. If you look in here, you'll see that 0 to 9 are the ASCII codes from 0 to 9, and A to Z are the ASCII codes from A to Z. So that's how we're able to reproduce what we're doing by using the ASCII codes. But beyond that, the values here are no longer the ASCII values. Now if you take 48, because here we're working with the number 48, and convert that to hexadecimal, that's going to equal to 30. So that's where we get our 0. If we add 48 to this, that's going to give you 60, and 60 in hex happens to land right on number pad 0. So you see there's a direct relationship between the ASCII code 0 and the number pad 0. It's basically offset by 48 decimal or 30 in hex. Same thing. So that's why we're going into here and adding 48 into our character code, because our code is actually in decimal. So if we find a match here, we're matching with a number pad number. If we're finding a match here, we're matching with a regular number that's being pressed on the keyboard. And again, we're handling the exact same way that we handled the text down below here. So now let's build this and test it out. Make sure we have our numbers working. So we can type some text, and then I'm going to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 on the regular numbers, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 on the number pad. So both of those seem to be working perfectly well. Now there's only one other set of characters I wanted to add into this function, and that's the lowercase letters. You'll notice that right now, anytime I type, it's always the uppercase that's being displayed on the screen. And that's because we're using the ASCII codes between 65 to 90. And between 65 and 90 happens to land on the capital letters of the alphabet. Well, what I want to display is the lowercase letters of the alphabet, unless you're pressing the Shift key, in which case I do want to display the capital letters. So to handle this, what we're going to have to do is change our console input function to add in an extra parameter, which will be the shift. So let's do that like so. We're going to add in a boolean. It's going to specify whether the shift is being pressed or not. And we'll go into scene.h, and where is it? Console input here. Need to change that. And we also now need to go back into here, and anytime we call console input, we need to specify whether we're using shift or not. The shift key is handled automatically for us using the key down structure here. So if we have this variable here, vk underscore shift, set to true, then that means we are holding the shift key down. If this is false, then that means we aren't holding the shift key down. Now that we have that in place, we can go back into scene console input and actually use this variable inside of our letter section down here. So if we find a match in our key code, we're then going to do the following. If we have the shift key pressed, then we don't want to display an uppercase letter, so we're going to do exactly the same thing we did before. However, if shift is false, then we want to use a lowercase letter. and the lowercase letters are equal to whatever the value was plus 32. And the 32 this time is coming from here. You can see if we have 65 and we add 32 to it, we get 97. 97 happens to be the lowercase version of whatever is being pressed up here. So that's the way we handle that, and we also have to increment and then return true. So now let's test this out to make sure we can get our capital letters and our lower letters working. Testing case sensitivity. All works. Alright, so there we go. Video was relatively short, and hopefully it's easy to understand. The general idea is we're basically taking the character code that is being passed into here, and depending on what the value is, deciding whether we want to save it inside of our array or not. Anytime we save it, we increment our counter so that the next time we save it, we move over to the next location. If we want to delete, we decrement our counter, we reset our value to 0 so that that letter disappears out of the array. And anytime we handle special characters, we just check for the special character key code, and then we type in the actual value that we're passing in here into the array. It's very important to use single quotes here when passing things into the array rather than double quotes. If you use double quotes, that's not going to give you what you want. I think the compiler will actually complain. So we have the echoing of a text to the screen. Come back for the next video where we'll be actually parsing this text and making it do some interesting things.